So, today I want to talk about the oceans warming faster and releasing carbon dioxide. Now, we've known for quite a long time that the increase in global emissions of carbon and other fossil fuel products would lead to an increase in air temperature around the globe, which would naturally have a profound impact on the world's oceans. The most common of the narratives that we've heard for decades centers around how glaciers would melt, sea levels would rise, and of course, how this would impact coastal regions generally through flooding and an increase of extreme weather events. Now, while this is all certainly still true, the impacts of the climate change that we've seen and the warming of temperatures in the oceans has actually been increasing at a faster than expected rate, and thus is increasing the frequency at which we see these types of climate disasters. In addition, it is having an impact that's only been relatively recently understood. Namely, the ocean is releasing carbon dioxide as it warms, instead of absorbing it as it previously has been understood to. So, we have here an article from The Guardian which explains a little bit more about some of the details here. The amount of heat accumulating in the ocean is accelerating and penetrating ever deeper, with widespread effects on extreme weather events and marine life, according to a new scientific review. One of the report's authors said that the devastating floods in eastern Australia had likely been made worse by warming oceans. The risks would continue to rise as the ocean took up more heat, the report had said. Now, it's worth noting that more than 90% of the heat caused by adding greenhouse gases to the atmosphere through burning fossil fuels is taken up by the ocean. Now, the rate of warming in the top 2 kilometers has doubled. This is 2 kilometers deep into the ocean. That has doubled from levels in the 1960s. The article in the journal Nature Reviews Earth and Environment had said. Now, to fully put this in its context, this is not that the temperature has risen by double in this span of time, but the rate at which it's accelerating has doubled in the span of 60 years. That is a disturbing trend, especially when 90% of the heat that is being caused by greenhouse gases ends up being absorbed into the oceans. When we factor as well that a lot of the carbon dioxide that we emit is being absorbed by the ocean as well, that is naturally going to have an impact that we will talk about shortly. Now, according to the review, the extra heat is accelerating sea level rise, intensifying extreme rain events, melting ice, adding energy to cyclones, and changing where they form, as well as causing more intense marine heat waves. Now, when we look at further information provided by the Washington Post, we see that scientists attribute about 40% of global sea level rise to the effects of thermal expansion in ocean water. Now, this may not be something that a lot of people think about, but when water increases in temperature, it expands. And therefore, that is going to see a rise in global sea levels. Now, again, we're talking about increased rates happening. So we're talking about all of this not just happening faster and more occurring more often, but the rate at which it occurs increasing over time. We're not just seeing a fast rate, we're seeing an accelerated rate. Warmer oceans also speed the melting of ice sheets, adding to rising seas. They disrupt traditional weather patterns and deepen drought in some areas. And they fuel more intense hurricanes as well as create the conditions for more torrential rainfall and deadly flooding. The authors cite one example from August of 2017 when the Gulf of Mexico reached the warmest summertime temperature on record to that point. The very same month, Hurricane Harvey had torn through the Gulf, exploding from a tropical depression to a major hurricane and dumping catastrophic amounts of rain on Houston and other areas. All of these things are part of the fact that there's extra energy available in the oceans. Now, again, we're seeing these rising temperatures trend towards more disasters becoming more frequent and more dangerous. The rare events are becoming more common and are being replaced with stronger and even more powerful rare events. And this is, of course, especially true as, again, the air is holding onto more water, the oceans have more energy available to it with the additional heat, and coastal regions are shrinking from these rising tides. Everything that occurs in terms of these environmental disasters are constantly cyclically expanding as the climate's changing. One event leads to another and cyclically affects the whole process. Now, in addition to all of this, we are seeing an analysis around the future warming that could cause precipitous drops in certain fisheries, causing the loss of livelihoods and food sources across the planet. The trend also makes it inevitable that marine heat waves will become more extensive and longer lasting, a reality that can trigger toxic algae blooms and fuel massive mortality events among coral reefs, kelp forests, and other ocean life. One example that we've already seen of this actually has to do with Alaska's snow crabs, because climate change is presumed to be have a massive effect on how they have had a mass die off. And the unprecedented step was taken to cancel their harvest season in order to save the species. Now, this is one of those disturbing trends. But we've also seen situations where entire oceans or entire seas off the coast of some of the Pacific West of the United States have seen large amounts of fish start to boil off and just die, just float to the surface because they literally were boiled alive by the increased temperatures. And we're also aware of quite a number of species whose sex is determined based on things like ocean temperature or acidity of the ocean, which again is going to be greatly impacted by the chemicals that we consistently pour into the ocean, and again by these rising temperatures, which could cause a situation where a lot of species can't even reproduce. And while I can't sit here and list the side effects of every single species that will be harmed by this, it's sufficient to understand that this is having a profound impact on marine life across the globe. And we have another effect that we really need to talk about, which is this release of carbon dioxide. Now, we have an example of this happening under the Mediterranean Sea that we'll look at in a moment. However, I do need it to be understood that it's happening across the oceans. It's not just centered in one location. And again, it's part of this cyclical process where, as the carbon dioxide is going to be released out of the Mediterranean Sea and the oceans, we're going to see a lot of these start to increase the rate even faster and even further. Now, we have here from Wired, beneath the surface of the Mediterranean, something odd is unfolding. A process called stratification is messing with the way that the sea processes carbon dioxide. Think of this part of the Mediterranean as a cake made of liquid, essentially. Fierce sunlight heats the top layer of water that sits on cooler, deeper layers below. Out in the open ocean, where water temperatures are lower, CO2 dissolves in salt water, which is what allows Earth's seas to collectively absorb a quarter of the carbon emissions that humans pump into the atmosphere. But as the eastern Mediterranean Sea heats up in the summer, it can no longer absorb the gas and instead starts to release it. It's the same type of phenomenon we see when somebody opens a bottle of soda that's been, carbonated. If you keep it cold, the dissolved gases will stay dissolved, but if you let it heat up, they can often fizz and pour out the top. Now, it's worth noting that in the Mediterranean, there's a whole other set of issues going on that is very much tied to this issue around aragonite crystals that has been found in sediment traps. This is a form of calcium carbonate, which oceanic creatures like snails use to build their shells, except in the increasingly hot eastern Mediterranean, it's forming what's known as abiotically. That's another sign that the water is getting so warm that it's releasing its carbon load. In addition, the article here talks a lot about how microplastics are having a profound impact and how some of the calcium carbonate could be sticking to it. And while that's kind of beyond the scope of all of that, it kind of all blends together as one major issue. Now, when we look at the wider oceans, what we have here in terms of information is presented to us by NASA, of all places, where we see as we burn fossil fuels and atmospheric carbon dioxide levels go up, the ocean absorbs more carbon dioxide to stay in balance. That's how it's been naturally occurring over time. But this absorption has a price. The reactions lower the water's pH, meaning it becomes more acidic. Now, remember what I said about the acidity increasing. It can have a profound impact on a lot of marine wildlife. Now, as the ocean has its limits, because of the temperature rises, carbon dioxide eventually leaks out of the oceans like a glass of root beer going flat on a warm day. Carbonate gets used up and has been restocked by upwelling of deeper waters, which are rich in carbonate dissolved from limestone and other rocks. In the center of the ocean, wind-driven currents bring cool waters and fresh carbonate to the surface. The new water takes up yet more carbon to match the atmosphere, while the old water carries the carbon it has captured into the ocean. The warmer the surface water becomes, the harder it is for winds to mix the surface layers with the deeper layers. The ocean then settles into layers or stratifies. Without an infusion of fresh carbonate rich water from below, the surface water saturates with carbon dioxide. And because of this saturation, the water can no longer absorb any of that carbon dioxide. The stagnant water also supports fewer phytoplankton, and carbon dioxide uptake from photosynthesis slows. In short, stratification cuts down the amount of carbon the ocean can therefore take up. So, this is one source that we're seeing here, but we've known about this type of thing for about at least 10 to 11 years, as there's an article here from 2011 that talks about quite the same phenomena. The oceans capture around 30% of human carbon dioxide emissions and hide it in their depths. This slows the march of global warming somewhat. So the ocean's really been our friend in all of that, making sure that the climate really doesn't change as fast as it could, but we're already starting to see it start to reach its limits in terms of how it's able to help us. Climate records from the end of the last ice age actually show that as temperatures climb, the trend reverses and we see the oceans emit CO2, which exacerbates warming. So there is historical precedence for this from the last ice age. But of course, now we're seeing this through a lot of the effects of fossil fuel production over our lifetimes. We're starting to see that actually come into fruition through human made climate change, and especially through capital created climate change. Now, when we see the rising temperatures, it makes carbon dioxide again leak from the ocean for two main reasons. Again, this was known about like 11 years ago. First, melting sea ice increases the rate at which the ocean mixes, which of course dredges up the CO2 rich deep waters. Second, when you warm the ocean up, just like warming a Coke bottle, it drives the gas out. So, while this is still relatively recently understood, 10 years is still relatively recent in terms of scientific terms, the fact remains that this has been understood long enough that we should have started doing something about it, and of course we haven't. And what we ultimately find here is that as the rising temperatures of the oceans continue to increase in its acceleration, they accelerate even faster. We will continue to see both extreme weather events and disasters continue to happen at a faster rate. But we're also seeing a situation where the ocean itself may no longer be able to hold onto the carbon that we've been putting in it. And additionally, it might release some of that carbon back into the atmosphere that it's been absorbing for years in a wake of sort of protecting the planet. But this is going to exacerbate a problem in a cyclical fashion, because as more CO2 spills into the atmosphere, we're going to see more increases in atmospheric temperature, which naturally means that the oceans are going to try to match, which is going to further stratify the oceans, which is going to mean it can absorb even less carbon dioxide and likely release even more. So we've kind of set ourselves up in a situation where this is going to happen for a long time. And unless we shut down these emissions almost immediately and stop this process, we will continue to see the damage accelerate. And we may not see the full effects of what this does for the oceans for at least a century. The fact remains that global capitalism and the perpetuation of growth models that constantly extract resources for profits is causing our oceans to literally be unable to help us in our fight against climate change by limiting the capacity of carbon that can even hold because it's reached its capacity already. We keep seeing these troubling signs that alert us that we need to move away from the free market as a even supposed solution, and we need to do this now. And as it keeps accelerating, these problems will just keep happening more and more, and we need to stop what we're doing immediately. So with that said, if you've learned something today, please do consider liking the video, subscribing, and leaving a comment, as well as joining my Discord where we have conversations like these. If you're in a financial place to do so, and only if you're in a financial place to do so, please do consider supporting me on Patreon, especially as political content like this can often be demonetized on YouTube, and it goes a long way to helping me produce more content like this. The links for everything that I mentioned are in the description down below, and with that said, my name is Anarchist Tara, and I thank you so much for watching.